Hello world! If you're new to scripting or if you've been wanting to learn how to script, let's get started today. If you're new to Jamf Pro and already know how to script, let's look at ways we can put them together. And if you're new to Jamf Pro and new to scripting, let's see what we can do for you. I'm William Smith, and most every day I work with customers just like you to put together workflows that quite often involve a little bit of scripting. Scripts are the glue that tie things together to help us make great experiences for our end users. What you see on the screen right now is considered the first computer program most everyone learns. It's the Hello World program. If you'd like to follow along with me, press Command Spacebar on your keyboard to open Spotlight. Type Terminal and press Return. This is going to open the terminal application where we're going to be spending a lot of our time. To make this just a little bit easier to read, press Command equal or Command plus several times to enlarge your text. And now type Echo Hello World and press Return. And be sure that you put quotes, single quotes, around Hello World. In this program, echo is called the command. The echo command means repeat what I say, and Hello World is called the argument. The argument tells the command what to say. Put them together, and your Mac is talking to you. Now, let's take that one-line Hello World program and add some more to it. I'm going to open my favorite script editor, BBEdit from Barebones Software. And I'm going to paste in several commands one after the other. You'll notice our echo command is on line 3. After that, I've added the sleep command. It means pause. My argument is 5. I'm going to pause for 5 seconds. Then I've added a few more echo commands to repeat something else, and in between those, I'm using a different command called say. All of these commands in a row make a script. Let's move this window over to the side, and we're going to save it. And let's save this as crazyones.bash. And then finally, I'm going to put it on my desktop to make it easy to find. To run the script, all I need to do is drag it into Terminal to fill out the full path and press Return. Let's see what happens.
Here's to the crazy ones, the misfits, the rebels, the troublemakers, the round pegs in the square holes.
So that's it. Now you know how to script and you know how to run a script. There's not much to it. All right, maybe there's a little more to it than that. Here's where we're going to spend the rest of our time. It's pretty cool that we can get our computers to actually speak to us with that say command, but scripting has a lot of very practical uses. We'll explore the reasons why. Is there magic in how Terminal works? To understand something like scripting, it helps to understand what's happening. We'll discuss Terminal. Once we understand the Terminal, we'll cover a handful of ways you can control your scripts and build in some intelligence. Then, we'll look at how you can incorporate your commands and scripts into Jamf Pro. And no webinar can teach you everything you want to know about scripting, so we'll finish with where to go next to learn scripting and improve your skills. Before we begin, for those of you new to Jamf, here's a quick summary of what we do. Jamf helps organizations succeed with Apple. Jamf Now is for smaller organizations with basic MDM needs and requires no IT, whereas Jamf Pro is our more robust management solution for a larger enterprise, education, or government customers. With Jamf Connect, an end user can unbox their Mac, power it on, and access all the corporate applications after signing on with a single set of Okta or Microsoft Azure credentials. Jamf helps more than 26,000 organizations to manage more than 13 million Apple devices, and we serve key markets such as the top tech companies, F500 companies, most valuable brands, the top marketing group, and over 14,000 schools. First, I'd like to ask you about your comfort level with scripting. We'll leave this poll up for about 30 seconds, and then let's see how much diversity we have with the scripters who are out there. We all start at the beginning. I started about 25 years ago with AppleScript. I had users who needed to FTP files over the internet using a $10 shareware application called Anarchy, or Anarchy as it was actually called. The way I learned scripting was to take the sample Apple scripts that came with the Anarchy and app, and then I edited those in the AppleScript editor. All I had to do was just change the URL in the file and then save the script as a droplet on the desktop. When my users were ready to send files to our vendors, they just dragged them on top of the droplet, which launched Anarchy, and off they went. It took only a few seconds to teach someone how to send files, and so long as they dropped the files on the right droplet, they always went to the right place the first time. All right, let's end the poll. Let's see the results. So from here, I see we have probably about 25% of you who are saying you can write your own scripts. That's great. I hope I can give you a little bit more information about some of the underworks of how Terminal works to make this a little bit more interesting for you. But the majority of you are saying I can take somebody else's script and I can modify it. That's perfect. You really don't have to have scripting chops in order to be able to use scripts with Jamf Pro. And then I see about 3% of you say that scripting terrifies me. I was there in your shoes about 25 years ago when I was trying to figure out how to send all these files over FTP. So I understand where you're coming from. All right. So why should Mac admins and Jamf Pro admins learn how to script or just use scripts? Let's talk about a few reasons. There's probably more, but I'm going to touch on 3. Scripting lets us simplify. We can reduce something complex like navigating this maze to a set of basic instructions. To solve this maze, we only need to know 4 commands: up, down, left, and right. The script takes care of the order of the commands. Now, while there may be 54 steps to solving this maze, if you have the instructions, solving it is easy. The length of a script doesn't mean it's a complicated script. All we're doing to solve this maze is break down the problem into small steps. Scripting lets us automate. To open a file on your computer just takes a double click. To open 2 files on 2 computers takes 2 double clicks on 2 computers. Now that's not too hard if both computers are near you and you have a mouse in each hand. How about opening 4 files on 4 computers at the same time? Okay, we have a mouse in each hand and we've pulled off our shoes for the second 2. Not easy. Not easy at all, but it's doable. But 8 files on 8 computers? All right, now things aren't scaling very well. At most, we could double-click and open only 4 files using our hands and our feet. That means it's going to take us twice as long as it has before to open all those files. How about 24 files on 24 computers? Not only have we run out of room on our desk, now we're having to ask a couple of our coworkers to help us. Also, not only have we doubled the amount of time it takes to open all those files, now we've tripled the number of resources we need to open all those files. Triple the resources means triple the cost, and triple the cost means you have an unhappy boss. All right, do you see where I'm going with this? How about 80 computers? Most of you probably have far more than that. With a simple one-line command, open, along with Jamf Pro, we can automate opening that file on dozens, hundreds, or thousands of Macs. Here's what that looks like when we run the open command in Terminal. I'm going to quit BBEdit and close my crazy one script. Then in Terminal, I'll type open and drag my script from earlier into the window to fill out the path and press return. Just as if I double-click the file, the open command opens the file, which also launches BBEdit. Or what if instead I wanted to open a web page instead of a file? The open command does that too. We'll just tell it the URL, and then also which browser we want to open it with, Safari. Scripted automation also helps us reduce the errors in our routine tasks. I recently visited a customer who had several years of experience with Macs, but he wanted he was somewhat new to Jamf Pro and also new to scripting. I asked him if he was comfortable with scripting, and he said, "I've never really needed it." So we were enrolling some new Macs, and then once they were done, I asked if there was more to the setup, and he said, "We'll just have the technicians do it." So I asked him what that meant. After his Macs were enrolled, the technician then sat in front of the Macs and started down a 47-item new Mac setup list to configure the rest of the settings. It took about an hour to do each computer. On top of that, it was prone to the technicians missing some items, and almost every time, because they'd done this so much, they missed some stuff because they were doing it from memory. Users were later calling the support desk because their printers were missing or their email wasn't configured. So we started scripting a few of the items, and before we were done, we could definitely see that not only would we be saving a lot of time for the technician, but also the support desk and the end user. Most everything in his new Mac setup list could be added to a script and then run in just a few seconds. We script for a few reasons. Scripts help us simplify our workflows and break them down into smaller, easy-to-understand steps. Remember, a long script doesn't mean it's a complicated script. They let us do the same thing on multiple Macs that would be impossible to do efficiently by hand. With Jamf Pro, you can perform the same task on multiple Macs around the world in just a few seconds. And finally, scripts eliminate the mistakes that we're prone to make when we perform tasks manually. They let us create a consistent user experience. Let's dig into how Terminal works. Understanding this greatly demystifies scripting. First, we'll talk about interpreters. Now stick with me on this. Believe it or not, you've already been using interpreters your entire career supporting computers. In fact, you've been using them ever since you've been using computers. The most common interpreters in the world are the Windows Explorer and the Mac Finder. Their job is to interpret your mouse clicks and your keyboard commands into computer actions. If you click a file, both Explorer and Finder interpret that as you want to select the file. If you double-click a file, they both interpret that as you want to open the file. However, if you've ever gone back and forth between Mac and Windows, you may have noticed that if you select a file in Windows Explorer and then press return, it opens the file. Whereas if you select a file in the Mac's Finder and press return, it lets you edit the file name. Not all interpreters will interpret your actions the same way. Just like when you log into your Mac and the Finder starts, when you open Terminal, it logs you into an interpreter. It's called Bash. Bash is short for Born Again Shell. That's its full name. It's simply a revised version of the Bourne shell written by Stephen Bourne 42 years ago. Bash celebrated its 30th birthday this month. Happy birthday, Bash. Terminal itself isn't an interpreter. It's just a window to the interpreter sitting behind it. There are other command line interpreters besides Bash on your Mac. There's the original Bourne shell, the C shell, the Corn shell with a K, one you may have heard about recently called Z shell, which Apple's going to make the default shell in Terminal starting with Catalina. Now, should you really worry about that? I'm going to say not really. Z shell is just an extended version of bash. For the most part, scripts you write for bash will work just fine in Z shell. You may have heard of Python, which is a very popular interpreter and scripting language for Mac admins. It looks and behaves very differently from bash, but it's cross-platform, which means you can write scripts that will also run on Windows and other operating systems. I'll point you to some resources for learning more about Python towards the end of the webinar. And Perl. It's just about a year older than bash, and its use has pretty much fallen out of use in favor of more popular languages such as Python or even PowerShell on Windows. For our purposes, we're going to stick with just the default bash interpreter. One of the reasons why anyone who's not familiar with scripting is intimidated by it is that they don't know how the commands work. Many commands, like those we've seen so far, are pretty straightforward and they're easy to learn. But just how many commands are there? Let's explore a little. I'm going to open a new Finder window at the top of the Macintosh hard drive, and then I'm going to press Shift-Command period to show hidden files and folders. The first folder I'm interested in is this one called bin. Bin is short for binary. Let's open it up and see what's inside. This folder contains about 35 items, some of which we've already seen before, like echo and bash. The makedir binary is the command for making new directories or folders. And there's the sleep command. Whenever we call a command in terminal, it's looking here to find those commands. They're just files. Think of these like single-purpose command line versions of the apps you see in the applications folder. Each binary does just one thing, like moving files, deleting files, or providing an interpreter for running commands. The binaries we find in the bin folder are some of the most common binaries that we'll use in scripting. These are very practical, and they're also the ones that are going to be used when we boot very early in the Unix operating system. Now let's move the bin folder to the side. The next folder that we're going to explore is sbin. It has 62 more binaries in addition to the 35 from bin. This is another folder of binaries that loads early in the booting of the operating system, but these require root or administrator privileges to use them. The standard Mac OS user can't use these. The S on sbin stands for super user. Some of these are responsible for mounting disks or file shares, or shutting down and restarting the computer, or checking and repairing the integrity of the file system. Now we're going to move into a folder called USR, which is short for Unix System Resources. And in here we find there's another bin folder. More binaries. Look at how many we have here. 969. This is where the vast majority of the command line binaries that we're calling in terminal live. These are general, system-wide binaries that aren't critical to the operation of the operating system itself, and any user is allowed to call them. You'll find some interesting ones in here like cal, which displays a calendar in terminal, or caffeinate, which prevents your Mac from going to sleep. This is a treasure trove of commands you can call in your scripts. And the last folder we're going to look at is another sbin folder in the USR folder. Again, the S in sbin stands for superuser. These are general-purpose binaries for controlling system-wide features like printing or scheduling tasks, managing system sounds, and changing file permissions. They aren't critical to the operating system, but they still require an administrator to use them. This adds another 237 binaries, each with a very specific and unique purpose. When totaled, these 4 directories provide us more than 1,000 commands that we can use in terminal and in our scripts. Now, should you learn what each of these commands does? Not really. That's going to be pretty overwhelming. Instead, when writing your scripts, think about what you do in the Finder, and then go find the command line tool that does the same thing. Use Google if you need to. If you can do it in the Finder, you'll be hard-pressed not to find a command line tool for it. And if you install third-party software like Jamf, they may include their own command line tools in the USR local directory, which is for binaries that don't come with the operating system. Here's a challenge for you. Throughout your day, while you're working on your Mac, pick something that you're doing in the Finder and try to find a way to do the same thing or something similar in Terminal. I'll give you an example. I'm going to create a folder on my desktop named My Stuff. Then I'm going to create a file with the quick brown fox, jumped over the lazy dogs, and I'm going to save it to my desktop with the name Brown Fox. Now, I'm moving my text file into the new folder. I'm opening that folder to verify my file is there, and then finally I'm going to delete the folder with the file inside. Now, what does it take to do the same thing in Terminal? I'll show you. I'll open a new Terminal window and press Command plus or Command equal sign a few times to enlarge the text, make it easier to read. The first command I'm using is makedir, which is short for make directory. For the argument, I'll tell it I want to make the new folder on my desktop, My Stuff. I'm going to use the echo command to create my sentence. And then I'm going to redirect it with this angle bracket or greater than symbol to create the Brown Fox file on the desktop. MV stands for move. I'll move the file into my folder. And here's the open command again, this time opening the folder on my desktop. And then finally, the RM command means remove. The -R that I'm adding to it means recursively, or remove the folder and its contents. And one other thing, the remove command didn't move the folder to the trash, it removed it immediately without warning. So be very careful with commands that cause change or delete things. Now let's make a script out of the work we've just done. I'm opening BBEdit to start a new file. Let's move its window over so we can see it and the terminal side by side. The first thing I'm going to do is type a line at the top of the script called a hashbang or a shebang. It's a combination of the pound or hashtag symbol plus a bang, which is an old typesetting nickname for an exclamation point. I'm following the shebang with the file path to the interpreter I want to use. When my script runs, I want bash to run it. This is similar to using Finder's Open With feature when you can't right-click, or where you right-click a file and you tell it, I want this application to open it. You may also remember from earlier that the bash binary is located in the bin directory. So the full shebang line is #bin/bin/bash. And there's no spaces anywhere in this line. From here, I'm going back to Terminal and select and copy my first command, the make directory command. And I'll paste it into my script window. I'll add a blank line below it just to make it readable. Blank lines are free. I'll copy my echo command and I'll paste it. And then for the rest of the commands, I'll just use the keyboard shortcuts for copy and paste. Copy and paste move. Copy and paste open. And then copy and paste the remove command. We have a shebang, and we have 5 commands in our script. Each command is on its own line with its own argument, saying what to do. Let's save the script to the desktop as folderfile.bash. And then notice that once I save the script, BBEdit changes the color of the parts of the script. This is called syntax highlighting, and it's really useful to see the various pieces of the script. My commands are colored in blue, and my arguments are colored pink. This is a great reason to use a plain text or a script editor when creating your scripts. It's very handy to see the differences. I'm going to close my script window, go find my script file on the desktop and drag it into terminal to fill out the full path. Now, as soon as I press return, watch very carefully what happens. Are you ready? Here we go. If you weren't watching closely, you missed it all happen. The script ran all 5 commands in just a few milliseconds. Did I mention another good reason to use scripts is they're fast? Before we wrap up this section, let me remind you that if you're new to scripting, you've already learned about 7 commands and you've just now seen them in action. It's not that hard to do some really useful things with just a handful of commands. Not bad. To recap what we just covered, we've discussed interpreters and that you've been using them ever since you've been using computers. Remember that the Windows Explorer and the macOS Finder are types of interpreters. The default command line interpreter for Macs today is the Born Again Shell, or Bash. We also covered where commands live on your computer. You can see them all if you show hidden files, and there's over 1,000 binary command files at your disposal, many of which do the same things you can do in the Finder. And last, when creating a script, always start it off with the shebang. The shebang is what tells your computer which interpreter to use when running your script. Now let's move on to how scripting works. I can't cover everything, but I will cover the most commonly used scripting conventions that most Mac and Jamf Pro administrators will use. We'll start with variables. Variables are like fill in the blanks. They're placeholders for information that's going to come later, like the blank space in this name tag. The reason it's called a variable is that it could be anything. We just don't know yet until we actually need to use it. The script on the right uses a variable called myname. It's best to name your variables something meaningful so that you can understand how you're using those variables later. We assign a value to the myname variable using the equal sign followed by whatever we want the value to be. Here, myname is the same thing as or equal to Martin. When we're ready to use the variable, we put a $sign in front of it. Let's drag the script into terminal and run it. Notice the echo command replaced the myname variable with its value instead. Here's something really cool you can do with variables. You can take the results of a command and use them as a variable. The software version command tells us information about the Mac OS. When we run it, it returns the name of the OS, the version of the OS that we're running, and the build number. That's pretty useful, but what if all we're really after is just the Mac OS version, 10.14.5? From experience, I know I can run the software version command with the -product version option, and it gives me just what I want. Let's look at how we incorporate that into our script. Our variable now looks like this. We still have the $sign, but instead we're using the software version command as our variable, and we're putting it into parentheses. If you think back to your school days when you were learning algebra, you may remember that expressions inside parentheses are evaluated first, and then you take their value and work with the expressions outside the parentheses. That's what's happening here. Let's drag our script into terminal and run it. The echo command evaluated the software version command in parentheses first, and then echoed its results as part of the full argument. Pretty neat. Sometimes we want our scripts to make decisions on our behalf. This is where conditionals come into play. Up until now, our scripts have been running from top to bottom and then ending. But what if we don't know what the ending is going to be? What if we want the script to tell us the ending? We need an if-then statement. If-then statements are decision makers. We give them the conditions that need satisfying and then tell them to evaluate whether conditions are true or false. For example, if I have lemons, then I will make lemonade. Here's how we add some smarts to our scripts. On line 3, I'm running that software version command between the parentheses and putting that result into a variable named OS version. Below that, I've created an if-then statement. These begin with the if condition and end with phi. That's if spelled backwards. The first line is the condition that must be met before proceeding further. If the value of variable OS version is equal to 10.14.5, then go to the next line for further instructions. Let's drag this script into terminal and see what happens. We're reacting to the if condition being true by displaying the message "No upgrade needed." So can we react to the if condition being false? Certainly. All we have to do is add an else statement and then specify what we want to happen. For this, I'm going to add a command using the Jamf binary, telling it to run a policy to upgrade the Mac OS. And I'm moving the else over just to make it pretty. Now we have a script that does more than tell us whether our Mac OS is up to date. If it's not up to date, it's going to take action. Another conditional is the while statement. It's similar to the if-then conditional, but instead of evaluating whether something is or isn't true, it instead waits until something is true. Similar to if, the while condition evaluates whether something between its square brackets is true or false. We're running a different command here called pgrep to determine whether or not a process is running, in this case the text edit process. The next few lines between the do and the done statements tell us what should happen while text edit is running. We'll echo that we're still waiting for the process to quit. We'll wait 2 seconds with the sleep command, and then we'll evaluate the while condition. As soon as text edit is quit and the while condition is false, the rest of the script can continue. Let's see it in action. First, I'll press Command Spacebar and use Spotlight to open the text edit app. Now, I'll drag the script into terminal and run it. All right, now let's quit text edit and see what happens. Quitting text edit breaks the while loop and lets the rest of the script continue, which is text edit has just quit. In addition to variables and conditionals, for loops are frequently used to take action on files or processes. For example, we can run a list of files through a for loop, and it's going to rename each file in the list until it's done. In this demonstration, I'm using a couple of new commands. On line 3, I'm using cd, which is the change directory command. Here, I'm changing my working directory to my desktop folder. The tilde in front of it's just a shortcut for my home folder. On line 4, I'm running the ls command, which means list. This creates a list of items on my desktop. I'm assigning the results of that command to the file list variable. The next line is my for statement. Now, it may look a little odd because it's creating a variable and reading a variable at the same time. The line is effectively saying for each file in the file list, do the following. Echo that we're renaming the current file and use the move command to rename the file. The move command can both move files to different directories or rename files. Here we're going to prepend the name of every file on the desktop with webinar dash. Let's take the script and drag it into terminal. Now look at the names of the files on the desktop. And now let's run the script. It's going to happen very quickly. We have two commands running within the do-done statement. For each file on the desktop, it echoes that it's renaming the file. And all the files on the desktop now begin with webinar dash. That's some pretty powerful stuff for just a few lines of code. So far, we haven't really gone over about 20 lines of code with anything we've done, and many of those were just blank lines to make things readable. And our list has grown to 10. I quite often tell my customers that with just 10 commands, they can take their Jamf Pro administration from a 2 to an 11. Recapping again, variables are placeholders for things to come. We don't always know what our variable is going to be. Quite frequently, we'll use a binary command to read something from the computer and fill it in as the variable for us. We can take these variables and evaluate them with if, then, and while conditionals. These let us build intelligence into our scripts, where we can tell it to do one thing if a condition is true, or do something else if a condition is false, or keep evaluating until something becomes true. And for loops let us take the list of items literally over one by one and do something with them. So far, we've been running all of our commands and scripts in terminal in one Mac. How then do we use them with Jamf Pro? We'll start with one-liners. These are just simple one-off commands we've been using in terminal already. Wouldn't it be nice to just run one command on all of our Macs? That's very possible with just a Jamf Pro policy. By default, all Macs use an Apple time server to set network time. We can see the current time server by opening System Preferences, Date and Time, and I'm going to unlock the preference so that we can see it better. And then viewing the server for the setting, the date and time is set automatically. Right now it's set to time.apple.com. I'll close System Preferences and click into Terminal. And I'm going to run this command starting with sudo, which means superuser do. I have to be an admin to run this next command. My command is called System Setup, and the argument's going to be -set network time server. That's what I want to change. Followed by time.talkingmoose.private. That's the host name of the time server I want to change to. When I press return to run the command, it gives me the result. And now, when I check date and time, I see my time server is now time.talkingmoose.private. Let's close System Preferences, and back in Terminal, I'm going to copy that command to my clipboard. Because Jamf Pro runs with elevated privileges already, I don't need to include the sudo. In Jamf Pro, I'm creating a new policy, and I'm naming it Set Network Time Server to time.talkingmoose.private. I'm going to run this policy at recurring check-in once every week. I'm doing that because I consider this to be part of ongoing maintenance that I want Jamf Pro to perform. Last, I'll scroll down in the policy payloads list and locate files and processes and click configure. The very last field is the execute command field. I'll paste my one-liner here. And that's it. All I need to do is scope this policy to my Macs and click save. Practically any one-liner that you want to run in terminals is going to work here. Extension attributes let you extend your Jamf Pro database to include inventory items we don't collect natively. One of those inventory items is something called a battery cycle count. I'm going to choose About This Mac from the Apple menu and press Option at the same time to open System Information. On the left, I'm locating power, and then on the right, I'm reviewing my laptop battery's health. One of those items is called Cycle Count. Most every Apple laptop since 2010 has had a maximum cycle count of 1,000. Once your laptop reaches that maximum cycle count, you'll probably notice your battery doesn't stay charged as long as it used to. That's what this article at the bottom is talking to us about, the number of cycle counts. Knowing the cycle count helps you determine whether the battery is healthy, if it needs repairing, or that your laptop may just simply be ready for replacement. In Jamf Pro, I'm choosing Settings, Computer Management, Extension Attributes, and clicking the New from Template button. I'm filtering for battery and choosing the battery cycle count extension attribute. That's all we need to do. There's really no scripting involved when using a template. At the bottom, you'll notice a pretty long and complicated looking one-liner. You might recognize the $sign command variable. Inside the parentheses are several commands joined together to bring back just the battery cycle count number. The variable is wrapped inside result tags. This is what returns the value of the script back to Jamf Pro. This script will only run for the extension attribute the next time your Mac updates inventory. By default, that's once per week unless you've adjusted that setting. If you'd like to test this on your Mac without waiting, run sudo jamf recon in terminal. All right, let's save and see what this looks like. Under Computers, I'll run a blank search to return all of my computers. I'll click on my test computer, and then on the right, I'll scroll to the bottom. And my battery cycle count shows as 75. This also becomes searchable in advanced computer searches and smart groups. Now, as part of lifecycle management, I can create a list of all Macs with high battery cycle counts, and then plan to replace them during my next budget period. Of course, Jamf Pro is going to support full scripts. As you get more experience writing your own scripts, or you find scripts published online by the admin communities, you'll see your options to manage Macs is nearly limitless. And remember, scripts don't have to be long or complicated to be useful. They just need to do what you can probably already do in the Finder. I recently helped a customer who wanted to encourage his end users to upgrade their macOS operating systems to Mojave by the end of the month. For the first 2 weeks, at the beginning of the month, he put the Mojave upgrade policy in self-service, and he periodically emailed his end users saying that it was there and asked them to self-upgrade by the middle of the month. At the beginning of the 3rd week, he displayed a nag message on their screens of the users who hadn't upgraded. He asked again that they self-upgrade. Then during the final 2 weeks of the month, he displayed a daily nag message asking the users to self-upgrade, and he warned them to upgrade, that the upgrade would automatically install by a specific date and time. Here's what that script looked like for the final countdown dialog. Don't try to read it, you'll go blind. It's using a binary called the Jamf helper, and every Mac enrolled in Jamf Pro has this binary already installed. And here's what it looked like when it ran. It didn't cover the entire screen, and it allowed the end users to follow its instructions to close and save their work. The countdown timer that Jamf Helper displayed was also very persuasive. They had 5 minutes before the upgrade started automatically. They could click the upgrade button at any time. What they couldn't do was close the window. It was going to be tough love. To add this script to Jamf Pro, I'll go to Settings, Computer Management, and Scripts, and I'll click the New button. I'll give it a name. And then under the Script tab, I'll paste it into the window. The script editor in Jamf Pro has a nice feature that does syntax highlighting just like I showed you with BBEdit earlier. All you need to do is choose Shell from the drop-down menu to turn it on once, and your scripts are easier to read. One other tip about using scripts that's good to know is you can also add echo statements throughout your script, and those will echo back into your policy logs. That can be great for troubleshooting your script when it's being run by policy. To create the policy, I'll save the script, choose Computers, Policies, and click the New button. I'll give the policy a name, and then set it to trigger at recurring check-in. By default, that's every 15 minutes. And I'm going to set the frequency to ongoing. My policy is going to be scoped to a smart group of all Macs that aren't running Mojave. If someone restarts his or her computer to avoid the upgrade, I'll know it, and the policy will just start again in 15 minutes. Then, I'll scroll down to the bottom and set an activation date and time so that the policy becomes active only at the end of the month. This way, I can set up my entire month's upgrade at one time, and my policies become active as needed. Now, I'll click the Scripts payload and add my Jamf Helper script. I'm also going to change the script's priority to Before. That makes sure it's the first thing to run when the policy executes. And then finally, I'll scroll down in the list of payloads toward the bottom and choose Files and Processes and put my one-liner in to upgrade the Mac. Some of you may have seen this one-liner before. It's called Start OS Install. It's perfect for erasing and install your computer or just upgrading your computer. And it's built into the installer for Mojave and practically every installer, at least back to Yosemite. This one-liner assumes the Install macOS Mojave app is already on the computer in the Applications folder. I used another Jamf Pro policy to put that there earlier in the month. And the ampersand at the end of the line, that allows the policy to finish the computer so that the computer can restart. Now, all I need to do is just scope this to my non-Mojave Macs, and off we go. We added a few more commands to our list that you'll probably want to explore some more: System Setup and Jamf Helper. Reviewing what we just discussed, not everything has to be a script. If you only need to run a one-line command, just add that to the Files and Processes payload of a policy and scope it to your Macs. They'll run it just as if you were running it in Terminal. Extension attributes are a great way to begin scripting. The templates in Jamf Pro offer a lot of ideas and new commands that you might want to explore. And the results become something searchable when you're searching for specific Macs or making smart groups. And of course, Jamf Pro can run full scripts too. You'll create them in the scripts area and then add them to the policy to execute. Now here's where you go off on your own and start learning about scripts. Let me point you to a few places to get started. Are you a Jamf Cloud subscriber? Or are you in either K-12 or higher education? If so, you have access to our entire training catalog with more than 15 hours of short how-to videos that cover everything from help desk to engineer to administrator with basic and advanced courses. I encourage you to check out the scripting series with 15 modules and video lessons that each take about 30 minutes to complete. This will get you going on the right path. From there, explore the open source community on github.com. Open source software is free to use, and you'll find hundreds of scripts and projects on Jamf's GitHub page at github.com/Jamf. And if you want to see a lot of examples of short and long scripts for a variety of needs, check out my personal gist repository on GitHub. I've written many of these for customers and my own use. Practically everything here is a real-world example of something I've used. And if you're interested in the Jamf Pro API, I have several scripting examples there as well. Many of these are made to use or can be adapted to use with Jamf Pro. When you start scripting, you're going to want a good script editor. I've been using BBEdit from Barebones Software throughout this webinar. It's free to use its basic features, which are more than enough for scripting. If you'd like to unlock all the features, it costs $49.99. It's also available as an annual subscription in the Mac App Store for just $39.99. Atom is an awesome open source script and text editor with lots of community contributed modules to expand its functionality. As your scripting needs grow, it can grow with you too. You can download and use it for free. And then something price-wise in between BBEdit and Atom is CodeRunner. It costs $14.99, and it's got a really nice interface that lets you type your sample scripts or one-liners in one window and then see the results in another one. And if you haven't already joined the MacAdmin Slack community, sign up for it at macadmins.org. It currently has more than 25,000 Apple admins just like you who've joined, and there's hundreds of channels on very specific topics like Bash, Python, AppleScript, Z Shell, and two of my favorites, Jamf Nation and JNUC. That's our Jamf Nation User Conference. Come visit us this November in Minneapolis for 3 days of sessions, training, and visiting with other Jamf Pro administrators just like you, and I would love to meet you. All the scripts that I've been using and the links to resources that I've provided you here are available for download at jamf.it/101. Look for our blog post in a few days to follow up on this webinar, and visit Jamf Nation discussions to chat with me and other scripters. We're all here to help you succeed with Apple. Now at this point, we have about 7 minutes left. I'm going to start looking through some of the questions and see if we can answer a few of these before we conclude. Now, somebody is already asking about Z Shell and that it's been deprecated. One thing to keep in mind is that, Z Shell itself has not been deprecated, but actually Apple is going to make it the default shell. They're not taking out Bash, they're not taking out Python and Catalina yet, but they are changing over to Z Shell. That was mainly a licensing thing. But come whatever after Catalina, 10.16, if we're going to call it that, you'll probably notice some changes. But still, nothing stops you, if you're going to write your scripts in Bash or Python, from downloading and installing Python and Bash onto your Macs. You choose the environment, the shell, the interpreter that you want to use. So somebody is asking about extension attributes and if there's any way for those to be something other than true or false. Extension attributes, if you're going to be collecting any information from your Macs by script, can be anything. They can be the name of a folder, the contents of a file, a setting, whether or not a process is running at the moment, the current user. Extension attributes are basically anything that you can run in terminal and bring back some information. Then you can put that into Jamf Pro. Somebody's asking a really good question here about how do we run a command through Jamf as the currently logged in user. You might remember earlier I said that anytime that you run something in the execute field of a files and processes payload in a policy, that it runs it just like you ran it in terminal, except sometimes you actually don't want to run that as root. You want to run that as the current user. You can do that using a couple of different commands. If you'll join me out on Jamf Nation discussions, I have started a discussion right there. Do me a favor, ask that question there, and then I'll try to answer it with at least one example. But it is possible to definitely run something as the current user, not as root. And I see somebody says, I use that program. I think you're talking about Anarchy. Wow, you're old like me. So somebody is talking about the differences between Bash and PowerShell. I can't tell you too much about PowerShell, but I can tell you that is more of a Microsoft technology and is intended to be run on Windows. PowerShell is probably, if I had to guess, very equivalent to AppleScript. PowerShell can let you manipulate things and also control things, very much like AppleScript can do on a Mac. It can take action. But beyond that, I'm sorry, I don't know that much more about it. Bash by default is not an option on Windows unless you're running, I think, at least Windows version 10. Just the very most latest version of Windows has actually started including very similar command line functionality like Bash in those operating systems. Anything earlier than that, though, you're probably going to have to stick with PowerShell. And somebody's asking, is there a difference between scripting and programming? Yeah, if I had to guess, I'd say about 30 years. Programming is basically scripting, except maybe the end result might be something called a binary. Programming is still kind of done the same way. Some languages are considered to be programming languages, where others are considered to be scripting languages, but basically you're doing the exact same thing. Quite often, programming languages, though, might be compiled into something else so that it becomes like what we saw with all those variables in the USR bin folders, the USR sbin folders. All of those have more than likely been written out in some sort of language and then compiled so that they just run as if they're a single app. A script is really calling multiple resources to be able to run them, quit them as needed, run them again, quit them. A script is just kind of giving you from a top to bottom, do this, do this, do this, do that. A program generally has just one or a handful of functions. And somebody's asking, does adding blank lines make your script bigger? Not at all. If I had to say, maybe it will be a K, but technically it's not going to be anything that's very big at all. In fact, even some of your longest scripts are going to be tiny, nowhere near a megabyte. Maybe a few hundred K, and that's about it. But that has to be really, really long. So right now, we are kind of at our time. What I'd like to do is say thank you for attending, everyone. And before we conclude, I'd like to say that Jamf also offers more to help you be successful. Our professional services offer on-location or remote services to customize Jamf Pro for your environment. That's what I do every day here at Jamf. We also offer certification courses led by our training team. Become an expert in Jamf Pro and widen your skill sets. And then finally, we have a world-class support from Apple experts across the globe. We even offer 24/7 support with our premium support packages. Thanks for listening. Have a good day.